Hello.
Hello everyone. Good afternoon, dear authors and invited guests. Welcome to technical session 5D. Uh, I'm Jay Lalwani, moderator of this session. On behalf of Global Knowledge as Foundation and Knowledge Chamber of Commerce and Industry, it is my great pleasure to welcome you to the 7th International Conference on ICT for Sustainable and Development through Zoom. I hope you will enjoy 2 days of knowledgeable and interactive session today. There is a special note for the presenter. It will be given 8 minutes for the presentation and 2 minutes for question and answer. On 7 minutes, I will raise a gentle reminder. Uh, and there is other request that you all stay connected with us till the closing remarks. And if you have any query or update, you can write it to me in chat box. Just before we get started, I would like to introduce you to chair of this session, Professor Vinodha Tumar. He is working as assistant professor in Vishwakarma Government Engineering College at Ahmedabad, Gujarat. He has more than 14 years of experience in industry as well as academics. His research areas of data security, blockchain technology, and all AI. He is also involved with an expert team of professionals working in RPA, ML, and AI. Welcome, sir.
Thank you, Jay.
Let's start the papers. Our first presenter is Daksh Dave, and his paper title is Learning Analytics and Online Courses at Bayesian Belief Network Approach to Predict Success. Mr. Daksh, you can start the presentation.
Yeah, sure. Can I present my screen?
Yes, sir. Thank you. You can share.
Yeah, sure.
And please stick to your time.
Yeah, sure. So, is my screen visible?
Yes.
Yeah. So yeah, hi everyone. So the paper that we are going to be presenting today is Learning Analytics and Online Courses, a Bayesian Belief Network Approach to Predict Success. So for this paper, we have 3 authors, the Virendra Singh Nirban, Tanu Shukla, and Daksh Dave, myself. So coming to the abstract. So in the field of educational research, learning analytics is one of the prevailing areas of exploration. The study explores a part of learning analytics using a Bayesian network model to predict the success of the course in the online mode of education. Through the simulation results, it was found that the Bayesian approach can be used to suggest improved online instruction delivery methods, helping the instructors and students reform their practices to maintain a synergy for a successful running of the course. As a study was executed on engineering students, it could further be investigated. It could further be generalized using students of other streams for comprehensive understanding. The study reveals that the student synergy with the method of teaching, paper difficulty, and take-home assignments are found to be the main determinants of the success of e-learning courses. So in the introduction part in this paper, we have discussed the problem, solution, and the objectives. So what we want to solve? So the method of information delivery of the teacher and compatibility of the student with that information delivery method combined with the student's prior preparation and eagerness to learn are difficult to gauge upon by the instructor in a remote setting. So the solution that we propose is that with the help of learning analytics, developed using a given set of student data, we determine variables that would affect the student-teacher relationship and suggest reformative steps of action to the instructor. So what we want to achieve? So we see the probability of conducting an online course and its success. We analyze different types of factors in the e-learning platform and the factors on the student-teacher interaction. Coming to the methodology part. So in the methodology, we have the timeline, literature review, data collection, and the steps followed. So the phase 1 included the timeline for this. In the phase 1 included the literature review, designing the Bayesian network. We then in phase 2 formulated the method of the study. In the phase 3, we floated a survey, gathered the responses. And in the phase 4, we reported and analyzed those findings. So let's come to the part of literature review. In the past, what work has been done in the same field? So in 2005, Garcia and Patricio proposed a Bayesian network to detect the learning style of a student in a web-based education system to provide personal assistance to students using intelligent assistants. In 2007, Zhang and Zhuang proposed an intelligent tutoring system. Their assessment system determined what a student knows by Bayesian networks. This information is useful for an assessor to make decisions for the next step of learning. Chakrabarti Sinha in 2016 proposed an intelligent tutoring system. So the aim of this system was to replace the human tutor by a machine through using Bayesian network methods. And in 2019, Kondo and Hatanaka used a Bayesian network to find out the learning states of the students, which provided feedback to the instructors of the student that which students were likely to get a lower grade. Now we come to the quantitative data collection methods. So there were 3 steps that we followed. So the step 1 was we picked one electrical electronic department course, ADVD, analog and digital VLSI devices, from BITS Pilani for the study to be conducted upon. The student data was categorized and collected by floating a Google form, which had 4 main attributes. And the step 3 was to compute the sum and averages of all the questionnaire answers to draw conclusions. So the steps we followed were we analyzed the Google form responses, we formulated our data set, we then cleaned that data set for training, we split the data into train, test, we fed it into our type Bayes algorithm, we then created a Gaussian model, and for the final step, we tuned the hyperparameters to get the optimal accuracy readings. So now coming to the most important part, the results of the study. So here we'll be discussing 2 results. First one being the survey results and the second being the Bayesian network training results. So the survey results were, here there are 3 images. So these are just snippets of the responses that we had. So 82% people found that they preferred using mail as the primary communication platform. And in the second one, we can see that 42% of the people were satisfied with the communication platform that was used by their instructor. And 77% were not satisfied with the way the current course was proceeding in the online setting. So there was something wrong with the course. And in the Bayesian network training results, we proposed a correlation matrix. So in that correlation matrix, we would see that how does the change in one input variable affect the other input variable, whether they were positively or negatively correlated. So, then we checked the accuracy of our Bayesian network. We found that our Bayesian network accuracy was 72.22%, which was what we discovered. And then coming to the conclusion. So our conclusion includes the study findings and the areas of improvement. So in the study highlights, we found that our results show that the percentile scored was most positively affected by the amount of time spent by the student in browsing the e-learning platform and the primary communication platform that was used by the instructor to communicate with the students. And the percentile score was negatively affected by the question difficulty, take-home assignments. We mean increase in take-home assignments, a lot of reading materials, and whether the person provided quiz solutions or not. So yeah, and coming to the part of significant discovery, we found that for running the course successfully, instructor must not put a lot of pressure on students with strict deadlines, decrease the number of evaluative and materials provided, should focus on covering depth rather than width in the particular subject, setting up a difficult paper just so that the student doesn't get overconfident would backfire, as the morale of the student gets down and the student doesn't find an interest in that particular course. A higher student score relates to a higher interest evident from browsing history. Getting sufficient time to cover backlog and revise the previous concepts is important, and a large number of evals makes it difficult to do so. The course becomes more demanding as the number of eval increases. So the suggestions for future research. So we had assumed the input variables to be independent in the model. So each variable has an equal, we took it as equal weightage. So other thing we can do is that we can we can assign weights to them and see how one variable affects the another and find their interdependency relations, and then accordingly trainer model. So yeah, that's all from our side. So thanks a lot for for listening to us.
Yes, Dax.
Yeah,
Can you listen to me?
yeah, I can hear you.
Okay. I have observed that in your Google form, you have received 75 responses, right?
Yeah.
Okay. So as per the statistical analysis, I would like to give you suggestion. Okay. There is one comment and suggestion is that I think 75 responses is not sufficient for such kind of analysis. And I think you should include some demographic parameters. Do you know which are the demographic parameters?
Demographic means the place where the person is staying.
Demographic parameters means it means that the data from certain regions, data from certain gender, okay, data from certain age group, because we would like to analyze the perception of all the people.
Yeah, right.
Okay, so this is one of my suggestion. Okay, so
right.
You should gather the data from considering all the demographic parameters, and after that you can do the analysis so that you can have your perfect result.
Right, got it.
Okay, good.
Yeah.
Yes, Jay, who is the next?
Our next presenter is Athira KM, and her paper title is Multi-Node Li-Fi Communications Complaint with IEEE 802.15.7 standard.
Yeah, hi, Jay, and hi, sir. Hi, all. Can I share my screen now?
Yes, you can start your presentation.
Yeah, give me a minute. Let me just share my screen. Share. Let me know once the screen is visible.
Is it available? You can start.
Thank you. So good afternoon all. Myself Athira KM would like to give a presentation based on my research topic, which has been conducted along with my professor Dr. Shubhashri Datta Gupta. So this project is adhered to 802.15.7 standard. Outline of the presentation. Light fidelity is a wireless technology, and as its name implies, it is used for wireless communication with the help of visible light spectrum. Comparing with existing Wi-Fi technology, which is based on the radio spectrum, Wi-Fi is more safer, harmless, secure, and contains low power requirements. This works by modulating the light from the light source, which is transmitted and received by a photodiode as a receiver. LED bulb as a solid-state lightning device transmit data by flickering the intensity so fast, which is not perceived by the human eyes. So in this research scope, we are focusing mainly on the backlayer implementation for a Wi-Fi system. Hence, we are creating a VLC application which will later embed as a logic unit for MAC layer into an FPGA. So when we started with our research, we found that the multiple node communication and the functionalities associated to make this happen, such as association of a device, disassociation, also mainly synchronization into an OWPAN with theming and visibility support are not yet implemented in the MAC layer. Hence, considering this, we formulated a research problem to develop a medium access control layer that conforms to IEEE 802.15.7 standard specification for Wi-Fi, and we are focusing on mainly three topologies: peer-to-peer, star, and broadcast. And some of the functionalities which we are adhering are like initiating and creating the network beacons, supporting OWPAN association, disassociation, synchronization, and visibility and dimming support. To create our VLC application, we adopted MATLAB and Simulink environment. The logical scripts we wrote in the MATLAB environment and the time-bounded parameters such as a network flow, transmission of bit synchronization using a CSMA, CA, etc. are considered with the Simulink environment. Hence, after combining both the simulation and the logical components of MATLAB, we developed the VLC application. Now, to embed this logic into an FPGA, we use the add-on provided by the MATLAB called HDL coder. So this tool helps us to convert this into a Verilog or VHDL code, which will fed into the FPGA. Now, with the support of this MAC layer, logic embedded and physical layer in FPGA, LiFO system can be enabled with multiple devices. Here is the basic frame structure. We have only dealt with beacon data acknowledgement command frames in this research scope. So this is the workflow implementation of a beacon generation. So beacons are used mainly for two purposes. It is to notify the network availability, and it is to synchronize the data transmission between the devices using a network by a superframe structure. So at first, two devices initiate and act as coordinators, and they make their own OWPAN. Now, both coordinators will start sending the beacons continuously even in a given interval time. And it has been shown in the flow diagram. So once after that, devices on the other hand will receive and identify the network availabilities. So the available network they'll find, and they will pass this information to the higher layer that is called the network layer. Now, once they identify the nearest OWPANs, the devices will send association requests to the coordinators. The coordinator will send a respond back with some acknowledgements. So that has been shown here, association request and back. Once after that, processing this association request from the coordinator, and they will share a response back, either success or failure. In case of a success, what did happen that the device will receive a MAC shared address by the coordinator device, and the MAC sublayer of the devices will get reset with the OWPAN, corresponding OWPAN details of the coordinator. Now, in case of a disassociation, it can happen in two ways. So one is the coordinator can remove any of the devices it associated, and the second case is that any of the device can get removed by its own from the network. But in both cases, the coordinator will be removing the device from the network, and the MAC sublayer of the device will get reset with the default values. Now the devices are joined the network, and started using the network for sending the data. But here collision and unoptimized use of network can happen. To manage this, MAC layer is introducing the superframe structure to optimize the network utilization. Beacon is the starting point of a superframe structure. All superframe have an active and an inactive period. So in active period, it's divided equally into 16 slots. The first 10 slots are stabilized using a CSMA CA logic, and 11 to 15 slots are using contention free period, where the slots are dedicated to devices such as, for example, 11-12 is dedicated to device 1, 13-14-15 is dedicated to device 2, likewise. So after the active period, the network is going into an idle mode, and when finishing the again after finishing one super frame, again the beacon starts sending, and the same process is getting repeated. So in this way, the network is optimized in data transfer all from all the ends. But in case of Wi-Fi, a transmitter will be on only if the lights are on, and the transmitter for any data transmission. So during the idle time, what happens that since nothing is there to transmit, the coordinator will be switched off its light. This can bring problems when other devices are unable to locate this coordinator. To avoid this scenario, dimming and visibility support introduced. So even in idle time, with the help of a dimmer which provide dim light, the coordinator will be able to send a small sequence called FLP, that is a fast lurking pattern, in order to prevent the coordinator being not getting switched off its light. And in this way, the visibility support is also introduced. So this is a small scenario like how the dimming support has been enabled. So whenever there is a request happening, that it have taking care, but with the dimmer control, it getting dimmed light in the idle time. Now this is the simulation system we have created from scratch. It contains 2 coordinators and 3 devices. And this is a small scenario of a CSMA-CA workflow. And our individual modules are converted into Verilog and VHDL files with the help of HDL coder. So after that, it will get embedded into FPGA. So this is the screenshot of a successful code conversion in MATLAB to HDL coder, like to the FPGA friendly Verilog or VHDL code. This is a small screenshot of the successfully converted code of VHDL generated code. Now, once after this, we tried sending and receiving that data transfer, not just a small text snippets, but also images. So we created an image in MATLAB its own, and we started sending and receiving that files backwards from device 1 to device 2, device 2 to device 1 back, and it was successful. Some of the screenshot which I have shown. And as a summary, Wi-Fi is a harmless and secure, promising technology which is coming in the era, and it involves transmission and embedding data using the visible light beams, which is very safer and harmless. This research focusing on the MAC layer implementation, and we have tried implementing the MAC layer with MATLAB and Simulink for multiple node, mainly the multiple node communication with star and peer-to-peer and broadcast topologies for sending the data between multiple devices. Yeah, this is some of references. Yeah, thank you.
Very nice work you have done.
Thank you, sir.
One of my concern is that you have mentioned that this Wi-Fi is one of the harmless and secured wireless communication, right?
Yes.
So have you checked the system for any kind of security issues?
Secure means, for example, sir, if you are using this light inside a room, No, I mean most of the hacking methods, like have you ever like the other side hacking will not be. So that's why I mentioned like it's a secure promising, because when the lights on, then only the data transmission happen, and it will be like inside that network premise. So for example, it will be very safer inside a hospital room where we don't have provision to use the wireless mobile phones inside an ICU, but when it is coming into light, it is more secure, right? More safer. So
It is right. I can agree with you, but my concern is that have you tested this system for any kind of attacks, brute force attacks or any kind of external attacks?
okay, the system which we have developed is mainly focused on the multiple node communication. So far, the security side we have not sorry incorporated.
Okay. It's fine. Okay, good.
Yeah.
Yes, Jay. Who is next?
Next presentation is Venkata, and his paper title is Detecting Autism Spectrum Disorder Using DenseNet.
Hello, sir. Good afternoon. Like Venkat Satsai is on some emergency, so I am Alapad Ratnavaibu, presenter on behalf of Venkat Satsai.
Okay.
I'm sharing my screen.
Yes.
Sir, is my screen visible, sir?
Yes, you can start.
Coming to our paper title, it's Detecting Autism Spectrum Disorder by using DenseNet. These are all others names, and I am the presenter, Alapad Ratnavaibu. So this is the roadway. I mean, introduction and all these references up to references. Coming to the introduction, so basically, what is meant by autism spectrum disorder? It's a neurological disorder that once new generation or any people from old age, from a newborn infant to an old age people, at sometime they can face this issue. If the person or any people suffering from the autism spectrum disorder, they can't lead a normal life. Like they can lead somewhat an irregular life when compared to the normal people. They can't act smart, etc. The main cause of this can be majorly two factors. One can be genetics, it's a pass on with the help of genes like DNA, and environmental factors like the pollution. Pollution will be the main cause. Currently, if we want to whether the person is an autism spectrum disorder, like is suffering from ASD or not, we are having only two methods like an MRI scanning, etc. It will be much costlier and it will take much time as well. So hence we tried our machine learning algorithm to check whether the person is suffering from ASD or not, when he's an infant stage itself. Application, like we are giving input as a 2D image. This can be our input. Our algorithm will take an 2D image. With the help of this, it will give the output whether he's suffering from autism or not. Coming to the problem statement, there are so many machine learning algorithms. And existing autism disorder, like it will take, as I already mentioned in the introduction, it will take much costly like MRI scans, etc. So we are using a machine learning algorithm which will give us a quick resolution at low time and low cost. Coming to this, what algorithm we had used, we had initialized our CNN, like we had tried with number of CNN algorithms by basic CNN algorithm and combining with CNN with other algorithm and a hybrid algorithm as well, like CNN random forest and SVM support vector missions, etc. But our target is to reach, not reaching, we have to cross 92.3%, as 92.3 already has been quoted in some of the paper, but we are unable to achieve 92.3, greater 92.3 with normal CNN and hybrid methods. So we had used the CNN with the DenseNet, specifically DenseNet 201, and we had achieved 94.3%. Here the proposed method, as I mentioned, DenseNet 201, we had used the DenseNet CNN model. Here the functioning will be the similar to CNN model itself. I will tell you the CNN briefly in the next slide. In next slides. Like coming to the CNN architecture, it consists of convolution pooling layer, transition layer, and classification layer dense block. The convolution layer here it is, we have applied the filter for multiple times. It can be created as a feature map. Suppose if I, for the first filter, if it creates the forehead is an above the normal size, and the next step it creates the expression of the kid is not in an abnormal way. It will note down all the points and it will create the feature map. Coming to the pooling map, pooling layer, if the convolution layer catches more than 100 features or etc., it will reduce the unnecessary features and it will reduce the dimension of the feature map so that our algorithm can be processed in less time with more efficient manner. Coming to the transition layer, it applies a batch normalization and downsampling. Like downsampling, in sense, it will downsample normal layer so that it will be easy. And dense block, it acts as a connecting for all the layers directly with each other. This is the map, how it will take. Our algorithm will take input as an image face, and this is the feature map where the convolutional layer. And after this, pooling layer will be come to the action and it will reduce the dimension layers. And after that, DenseNet will take action. It will divide and it will connect with each layer. After this, directly the output will come whether it is an autism or not. Coming to the DenseNet CNN, we had used this as I already mentioned in introduction. Some slides are repeated. Sorry for that. Here the accuracy does not increases in other runs. So the main part is we had given the epochs. Epoch in the sense like 1 run, 2 run. 1 run is equal to 1 epoch. So if there are 100 runs and the accuracy and the highest accuracy is captured in the 59th epoch, and the machine learning will continue with the 10 to 20 epochs still. And at the if there is no increase in accuracy, the machine learning, our algorithm will stop processing for the further epochs, and we can declare that as a highest accuracy at 59th epoch, so that it can be so that our machine learning algorithm will save time and increase in efficiency manner. I had already explained this in layers of this. This is a block diagram for the. Here we will install TensorFlow, that's normal thing, and we'll collect the data set. Pre-processing will be done, like whether the blank values are there. We will do that pre-processing and we'll apply our CNN, a customized CNN, and we'll classify the image. After that, results will come directly. Like simulation, we had achieved by using normal CNN algorithm up to 70-80%. But later we had worked on DenseNet 201 and combined CNN algorithm. We had written our custom thing when we achieved our score accuracy 94.3. We had achieved our 94.3 score. That is, we crossed 92.5. Data set here it is, as I already mentioned in the starting, it's a 2D image for classification purpose. This is the performance measure. We have an you can see the image like we have a graph. We had achieved the 94.3% in visual manner. As I already said, results will give in result by we will give a 2D image as a data input and we'll get an output. Whether it's a 0-1 type like binary thing, whether the person is autism or non-autism. In this case, our algorithm approach is 94.3%. Yeah, conclusion, that's it. You can see the furthermore people are increasing the autism spectrum disorder. It can be helpful for each and other child. Those who cannot afford the AI scanners, it will be helpful for them to just take input of an image and it will give the output. If the output is an autism, so they can move to further process. Yeah, these are the references we have taken from. That's it. Thank you.
Okay, you have mentioned in your presentation that you have used custom CNN to achieve the accuracy up to 94.3%, right?
Yes, sir.
And you have achieved that accuracy successfully.
Yes,
now,
sir.
I would like to know that what is the limitation in your system that you haven't achieved more accuracy? It means up to 99% or 100%. So what is the limitation of your system?
Like actually we are using a 2D image, sir. I mean, just a normal 2D image. Like we did not include more and more features. Like it will be cost for us in computational way, and it will be scanner way. I mean, if we need to take an input of an MRI scans, etc., it will be costly and it will be more taking time. So we did not include that one, sir. Actually, we tried more than to achieve more than 95.
These are the limitations, and if you wish, then it can be further improved.
Yes, sir. It can be improved, sir.
Okay, so it is costly and time consuming, so that you haven't implement those system. Okay.
Yes,
Right.
yes, sir.
Okay.
The end
Yes.
product can be.
Jay, who is the next?
Oh, sorry.
Yes. Yes, you can continue. Yes, continue.
Actually, the end product can be a mobile app also, sir. So the individual can take a photo of their photo of the persons who are doubting themselves. So it results will be get in seconds only.
Okay, it means that it will be dependent on the device from where you can capture the photograph.
No, I mean face of the image.
Face of the person.
Yeah.
Okay. 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 It means that if you wish, then you can raise the accuracy up to 100% or 99%. It is possible.
Yes, sir. It is possible, sir. Of course, it will be possible.
Good.
Thank you, sir.
Yes, Jay.
Next presenter is Aishwarya Venugopal, and the paper title is Enable Deep Learning Model for Breast Histopathology Image Classification.
Hi, sir. Am I audible?
Yes, you can start.
Is my screen visible?
Yes.
Okay. Good afternoon, all. This is Aishwarya Venugopal from Amrita University. My research topic is Ensemble Deep Learning Model for Breast Histopathology Image Classification. I'm doing this under the guidance of Dr. Jyotisha Nair. These are the overview of my presentation. Introduction. Breast cancer is a deadly illness that affects people all over the globe. As a result, efficient and accurate breast cancer detection is critical. So early detection of breast cancer helps patients to get a best therapy. Numerous research have created computerized algorithms for predicting breast cancer with several imaging techniques. Here I'm focusing on breast histopathology images that was acquired using the microscopic scan of breast tissue. Here, the deep convolution neural networks are able to extract both global and local contextual information. An ensemble deep learning version is utilized to extract distinguished image features. That is, the pre-trained Inception ResNet V2 and EfficientNet V2 models are used in parallel. Then the feature maps are combined and reduced by dropout before fed to the last fully connected layer. This adopted an ensemble learning focuses both on depth and width. It reduces the variance of built neural networks. So the main challenges are like color variations in the tissue. And also, even if the deep networks have considerably improved representational capacity, they still suffer from feature reuse and gradient vanishing problems. And also, DCNN requires large number of training samples. And also the number of breast histopathology images is limited due to data privacy issues and higher acquisition costs. In the proposed work, we are using transfer learning for breast diagnosis based on histopathological images, and also color normalization. It used to tries to adjust the color values of an image. And this ensemble learning focuses both on depth and width. Thus, it reduces the variance of built neural networks. And also the concatenation of two pre-trained DCNN achieve an accurate multi-level breast cancer classification. In related work, the similar methods using like CNN plus SVM based approach. This method got an accuracy around 77%. Next is like DCNN plus RNN for image feature extraction. It got an accuracy reaches 97%. Then the ensemble VGG19 and VGG16 models, it got offered the sensitivity around 97.73%. Last is like enhanced feature extraction approach. It got an overall accuracy reaches 76%. In the research gap, training data might be insufficient for choosing only one lab. That is, which in the case of histopathological images, where small amount of data is only available. And the different distribution of histopathology images and the great similarity between the benign and malignant tumors make the classifications challenging for one neural network. So the problem statement here, I am aiming to improve the performance of learning instead of developing a new model, and also aim to provide a complete classification task that takes into account 4 classes of malignancy and 4 classes of benign. The virtue of this architecture is to provide a deep architecture based on efficient V2 and Inception ResNet V2 model. The dataset I am using here is like breakage and back dataset. For breakage, it consists of 4 types of malignant tumors and 4 types of benign tumors, around 7,000 images total. For back dataset, it was around 4 classes categories, that is typical, benign, in situ cancer, and invasive carcinoma. And also for back data set, to reduce the model complexity, we need to do patching. And also for breakage data set, it's an highly imbalanced data set, so we need to do the class normalization process. So this is the proposed method architecture. Proposed model is an ensemble version of model architecture, is proposed for the classification purpose. The proposed model consists of inception ResNet v2 and efficient v2. Both are trained on the ImageNet dataset. The top layer, that is the dense classification layer of both networks, are removed. For concatenation and fine feature extraction process, global average pooling followed by dense and dropout layer is added. Here, the gap layer is used to minimize the number of parameters and therefore avoid overfitting problem. So in the concatenated features are fed to 2 dense connected layers. The reason using 2 fully connected layers is to enrich the learning ability and to adopt the generic features of our histopathological data set. This is the TensorFlow diagram of our proposed method. Here, the inputs of 2 datasets are fed to the pre-trained EfficientNet and Inception ResNet models without the last fully connected layer. Their role is to perform the feature extraction. The features are then fed to the global average pooling layer. It processes dimension reduction on feature maps and prepare the model for the final layers. The extracted features are concatenated to form 1024 dimensional feature vector. That is, the 2 inputs are concatenated and proceeded by the dropout layer and then the last fully connected layer. This is the architecture for the Inception ResNet. Here, the Inception modules are similar to that of the convolutional feature extractor, but the cross-channel correlations and the spatial correlations are decoupled here. Inception ResNet v2 is based on the Inception architecture that have proven to achieve a very good performance and low computational cost. And also, moreover, the Inception ResNet v2 utilizes residual connections, which avoids the degradation problem. This is the architecture for EfficientNet. It introduced a unique compound scaling technique that consists of scaling parameters that evenly scales the network depth, width, and resolution for increased performance. Here also, MV convolution module with depth-wise convolution and fused MV convolution without depth-wise convolution is considered as the building blocks of this EfficientNet v2 architecture. The mobile inverted bottleneck convolution with compression and the stimulation layer is the foundation of this EfficientNet design. Here in the pre-processing stage, we are using Wahdani method, which is utilized for the stain density maps with stain color with refer to the target picture. Next is like image augmentation. It is used to avoid the classification overfitting. Here the data augmentation is based on rotation, flipping, shifting, and the intensity of the original images is also adjusted for the acquisition process. As we already said, breakage dataset is highly imbalanced dataset. So augmentation operations are applied on each class in the dataset with setting augmentation limit of class having the maximum images. Here we can see that the breakage dataset before and after class normalization. So the evaluation metrics considered is like F1 score, precision, recall, and specificity. Here we can see the results accuracy curve for back dataset. The proposed ensemble model, it got around 98%. The individual Inception ResNet model got around 95%, and the Inception EfficientNet model got around 95%. This is the accuracy curve for breakage dataset. For the proposed ensemble model, it got around 99%. This is the loss curve for back dataset, and this is the loss curve for breakage dataset. This is the confusion matrix. Here for the back dataset, we can see that it has 4 classes: benign, in situ, invasive, and normal. Here the 97% of benign is classified itself as benign. Similarly, for breakage dataset also, for the breakage it has 8 classes. So similar way we classified for the 8 classes. This is the performance comparison for model and back dataset. Here we can see that for the Inception ResNet model, it got an accuracy around 91%, and for the EfficientNet model, it got an accuracy around 92% for the back dataset. In the proposed ensemble model, we got around 98%. Similarly, for the breakage data set, the inception testnet achieved around 93%, and for the efficient net, it got around 95%, and the proposed ensemble model got around 99%. This is the model predictions for back data set and breakage data set. Here we can see that for the back data set, it consists of 4 classes, and for breakage, it is around 8 classes. So conclusion, here we are focusing both on depth and width. So the virtue of our approach is to take the advantages of these two semantic deep features. And all the overall accuracy of this classification of back data set is around 98%. And for the breakage data set, it was achieved around 99.36%. So these are some references. Thank you.
Okay, very nice work you have done. My question is that you have taken images as your data set as an input. So is there any minimum requirement of resolution of those images, or is there any specific range, or any kind of images are acceptable in this framework?
Any kind of images is acceptable.
Sorry, will you please repeat?
Any kind of images is acceptable, sir, because it's a global.
Means if there is a low resolution image, then is it possible that you can take as an input?
Low resolution, actually, I didn't try it like that, but after we already did the pre-processing, right? So
Okay. Okay, it's fine. If you haven't just done the testing, then you can try the low resolution images with this framework, so that you can have a better idea about low resolution images, that what is the result.
Sure, sir.
Okay, good. Yes, Joy, please, who is the next?
Thank you so much, Aishwarya, for a nice presentation.
Thank you.
Our next presenter is Ashwin Nambia, and his paper title is Peer-to-Peer Ride Sharing Using Blockchain. Mr. Ashwin, are you there? I think he's absent. We can go to next. Devashish Hatti, and his paper title is An Improved Static Technique for Replacement of Anchor Nodes to Enhance the Localization in IoT. I think he is also absent. Next presenter is Mohammad Osama Iqbal, and his paper title is Blockchain Technology in Decentralized Applications Using Blockchain.
Yes, sir.
So Iqbal, you can start your presentation.
Am I audible?
Yes, you can start.
Is it visible?
Yes, visible.
So the topic of my presentation is blockchain technology and decentralized application using the blockchain technology. So first we'll see what's happening. So we'll start by what is blockchain. So blockchain is a decentralized ledger of all transactions across peer-to-peer network. Using this technology, participant can perform transactions without need of central certifying authority. Like in day-to-day example, we can see a bank. Bank is a central certifying authority which intermediate transaction. Like one person want to send money to another person, the bank is the intermediate and which process the transaction. In blockchain technology, there is no intermediate, there is no central certifying authority. So simple analogy to understand the blockchain technology is a Google Doc. When we create a document and share it with a group of people, the document is distributed instead of copied or transferred. They all the people get the document, all the people have the rights, and if one want to change the document, that person must seek the permission from other as well to change something in that document. So this is simply a simple analogy to understand the blockchain technology. So we'll say there are types of ledger. There are two types of ledger, centralized ledger and decentralized ledger. Like we have taken example of bank. Bank is a centralized ledger. Like bank is central certifying authority that control all the transaction, all the input and incoming and outgoing transactions. Whereas in blockchain technology, it is a distributed ledger. Like if you want to initiate a transaction, or if you want to do some changes, or if you want to access some data, then you have to take the permission of all the nodes present in that blockchain. There is no central certifying authority that controls the blockchain. Every participant has equal rights, and they use the consensus mechanism to perform a transactions. So we'll see how transactions are done in blockchain. So suppose A wants to send money to B. The transaction is represented online as a block. The block is broadcasted to every party of that network, of that blockchain network. Those in the network approve the transaction if it's valid, and that node get attached to the chain of the network, and the money get transferred from A to B, and the transaction gets completed. Well, how the distributed ledger works. User initiates the transaction using the digital signature. User broadcasts their transaction to nodes. One or more nodes begin validating each transaction. Like when we initiate a node transaction, one node is created, and that node gets verified by all the other nodes. And once the validation is done and consensus is achieved, then the block get attached to the blockchain, and the transaction gets completed. So we'll see the advantage of decentralized ledger. So the advantage is transparency. User or developer have the opportunity to modify it as they see fit. They make the blockchain a particular secure technology. All the user and developer, they can modify the technology using the consensus of all the other parties of that blockchain. So there is the transparency, nothing is hidden. Reduction in transaction cost. As we remove the certain middlemen, and like bank, when we do a transaction using bank, the bank charges some amount of money, but in blockchain technology, there is no middleman, so transaction cost is also reduced. Faster transaction settlement, like bank work only for 5 days a week or 6 days a week, but blockchain work 24/7. We can perform transaction at any time, and it gets settled instantly. So faster transaction settlements. So we'll say the blockchain summary. Blockchain technology is an emerging technology that has been designed for managing a distributed ledger of transactions. The blockchain was traced back in 2008 while Bitcoin was introduced by Satoshi Nakamoto. Blockchain is a sequence of blocks in which each block contains some transaction that are validated by an encryption mechanism, eliminating intermediaries, reducing transaction cost, enhanced security, immutability, and transparency are among the major features. The use case of the blockchain is not limited to cryptocurrencies. Rather, today blockchain technology is applied in a vast range of domains, financial services, smart contracts, IoT, and several other things. So one of the main usage of the blockchain is decentralized app. So decentralized applications. Decentralized application, also known as DApps, are digital applications that run on blockchain network of computer instead of relying on a single computer. There is not a single data center or a single server that controls the entire application. Like in today's world, in Web 2.0, there is single server or single data center that controls the entire application or entire website. Because DApps are decentralized, they are free from the control or interference of a single authority. There is no single authority in blockchain. Benefits of DApps include the safeguarding of user privacy and lack of censorship and flexibility of development. Drawbacks include the potential inability to scale, challenges in developing user interface, and difficulty in making code modification. There are drawbacks, but after some time, when more people will start coming into this blockchain technology, and so it will grow on a larger scale, and all the drawbacks might go away. So these are a basic diagram from which we understand how the apps and how the DApps work. Apps have a single data center connected to Internet Service Protocol to that data center. If that data center shuts down, then the app will not run. But in DApps, there is no central data center. It is connected in a chain of networks. So there is no dependency of central authority. Although the concept of DApp is quite nascent, it has already obtained some core characteristics unique to its nature. So open source, the worldwide availability of the main source code. The main source code of the particular any app developed using the blockchain technology is open source. Decentralization, it do not have any central certifying authority. Incentivization, the provision of cryptographic token digital asset to the contributor. Those who contribute to that web app or contribute to that particular blockchain network get incentivized. So at the moment, there are two ways in which app reward their network participant: proof of work and proof of stake. The proof of work gives award to the piecework basis. Well, like how much transaction you have done, you will get reward according to that only. And proof of stake, the proof of stake ensures the participants have a block of voting rights based on their stake, like how many servers they have deployed or how many GPU they have deployed. Then according to their stake, they will get their reward. Like miners provide a huge capacity to that blockchain network, so they get reward according to their network. So there are several pros and cons. Pros are zero control authority, high level of database security, resistance, hacker attack, no system failure, ease of payment, etc. Cons are slow transaction processing speed. Right now, it's not slow, but yeah, comparatively it's slow, but it will grow time to time. Less efficiency of the blockchain when growing bigger. High energy cost. Yeah, energy cost is high, but reward is also high. So it will compensate it. So important paper that I reviewed. So there are several papers. One of the paper is like tokenization of blockchain, in which data is converted, plain text is converted into ciphertext, and data security is enhanced. One of the other paper is also based on the web app, Web 3.0, like blockchain enabling technology for transparent, accountable, decentralized public participatory GIS system. Then in this system, the web app is developed for the government, in which government allowed the land to the people. It is done through this app. There are several other applications of the blockchain as well, like in security, biometric authentication, also cryptocurrency, health record. Various DApps have various industries in which DApps can be decentralized application can be used, like in blockchain network, Internet of Things, banking, finance, artificial intelligence, virtuality. Many other sectors are there. So one of the important sector is healthcare. In healthcare, we store the information of the individual patient on the blockchain network, and it will get more secure over, and their health record of a particular person cannot be leaked. It is basically a sensitive data. So we can store that information on a blockchain network. Analyze the effect of a particular procedure. If we do some experiment, or if we do some procedure on some patients, and we store that data on blockchain and analyze that data when we require. Safety and transparency. There's a lot of safety for the data in blockchain, because blockchain is a highly secure network. One other important implementation is supply chain management. Supply chain, blockchain-based pharmaceutical supply chain can also be developed for the supply chain of medicine and other drugs. For the supply chain, blockchain-based transparent decentralized tracing solution can also be made, like from blockchain network. Once the package is getting transported, the data of that package is uploaded on that blockchain network, and it can be traced how the transport on every path the data is uploaded on the blockchain network, and we can trace that path. Blockchain-based cross-border trade and global supply chain. And there are several supply chain can also be done using blockchain. Education, other important is education. One of the example is University of Nicosia and Birmingham Research Center have used blockade system. A blockade system approves control of issue of personal official documents, academic certificate, and private data. The domain of the universities make use of hash certificate in the blockchain for verifying student certificate. An authenticated employer can verify student certificate and issue a hard copy or based on the blockchain integrity. So we'll see the future of the decentralized application. We focused on Ethereum. Mainly right now, the DApps are mainly focused on Ethereum because they are made using the Solidity language, which is the Ethereum blockchain network. But there are a number of other competing technology developing as well. One of which is Ethereum. We anticipate some of the conflicting and redundant systems to merge in the months and years ahead of blockchain innovation. Polkadot is one example is a platform that combines and connects many blockchain subnetworks. Under shared security mechanism, Bitcoin and Ether could trade with one another. The trading mechanism can also help in growth of the trading market blockchain, which grows the wealth of individuals. So the conclusion, the apps have grown into DApps as a result of blockchain technology. Right now, it's Web 2.0, but in coming future, the apps will grow into DApp, a decentralized world. So DApps are superior to standard apps as they have ability to become self-sustaining resource by enabling stakeholders to contribute in decentralized application development. DApps will be favored over presently offered traditional application for a variety of purpose in near future, including payment, storage, cloud computing, and so on. The adoption of the blockchain is unavoidable, and many present processes will become obsolete as a result. Banking services are already preparing to implement the blockchain in the near future, because banking services require high security, and blockchain provides that high security, which will enable them to operate with trustless, self-sustaining, and decentralized work. These are the references of the paper that I have reviewed. Thank you.
Okay, my question is that I am sending you Ethereum
Yes.
from my wallet
Yes.
to your wallet address.
Yes, sir.
Okay, so it is a transaction. We can say it is a transaction. So
Hello.
Sir, you are on mute.
how the transaction on Ethereum blockchain will be confirmed?
Basically, my paper part is basically the decentralization of the app. I have reviewed the paper of decentralization of an app, how the decentralization works.
And the question is a basic question. Okay, yeah, you can refer it on Bitcoin blockchain, Ethereum blockchain. You have mentioned that it is a proof of work, proof of stack. Okay,
Yes, sir.
so it is a confirmation of the transaction. So it is
Yes.
the basic initial fundamental concept that all the transactions are verified and confirmed. After that, the block will be listed on the blockchain.
Yes, sir. Yes, sir.
Okay, so this is the part of some basics.
Yeah.
Okay, it's fine. You can refer it. Okay.
Thank you, sir.
Jay, please introduce the next presenter.
Thank you so much, Iqbal, for your nice presentation. Our presenter next is Devashish, and his paper title is an improved static technique for placement of anchor nodes of enhanced localization in IoT.
Yes.
You must start and stick to your time.
Ah.
Thank you.
Is it visible?
Yes, please stick to your time. Thank you.
Yes. So, esteemed session chair and the audience, a very good afternoon. I am Devashish Sati, faculty, KIT University, Odisha, Bhubaneswar, and presenting the paper titled as an improved static technique for placement of anchor nodes to enhance the localization in IoT. So let me start with the overview. IoT is the Internet of Things or a collection of sensors and actuators, and generally they communicate through wireless medium. And most of the IoT applications, they require the positions of things.
Dear presenter, your 22 number slide is
Yes.
so you can start with first slide.
Yes. So the most of the IoT applications, they require the position of things which is required for tracking or navigating or monitoring and controlling. And the localization process is divided into two phases. The first one is the distribution of anchor nodes, and the second one is the effective computation to find out the positions and to reduce the positional errors in the network. So my discussions deals with the first phase. And this is my content: introduction, motivation, problem statement, literature survey, proposed work, result, conclusion, and reference. Just a minute. Yes. So what is exactly an anchor nodes or beacons? So localization is the process of finding the unknown location of the sensor node in the network with the help of a reference node, and that reference node is called anchors. And while localizing a thing or localizing a node, there are a variety of challenges are there. First, the power, reachability, cost, and accuracy. Because the sensors are battery powered, so the power is the constant. Reachability, generally, some of the applications, they are deployed in the remote area, terrain, forest.
Excuse me, sir.
Yes.
We are having your slide of results. So is it possible that you can show the slides from the beginning?
You can just click F5.
This one?
Your
F5.
visible slide is slide number 22.
Just a minute. Slide number 22.
So you can start from slide number 1.
Okay, just a minute. Slide number 22. This one? Yeah, this is slide number 22.
Yes, you can
Yes.
start from 1.
Here only.
Is your presentation will start from this slide?
No, it starts from the beginning, the first one.
Okay, you can start from beginning. Yes.
Yes,
So
you
can
can
I
click on the
Just
slide.
click on the
can-
first slide. Click on the first slide.
This is the first
Yes.
slide. Is it
Yes,
visible?
yes.
Yes.
Now you can start.
Okay, thank you.
And
So,
stick to your time.
yes. So these are the major challenges for while you're calculating the localization of a node: the power, reachability, cost, and accuracy. So generally, the sensors are battery powered, so power is the constraint. Reachability, most of the applications they are deployed in the remote terrain or remote places, indoor areas. So reachability, there is a lot of obstacles. So reachability is another constraint. Cost related to your processing time, memory, and bandwidth. So cost is also a constraint. And accuracy is there are three major things, that is low computational capabilities, non-GPS based reference coordinates, and wireless impairments. They do not provide the right kind of positional value of a particular node or the sensor or the thing. So generally there are two types of techniques to calculate the localization. One is the geometrical approach, one is the training dependent approach, but my paper deals with the geometrical approach. In geometrical approach, that uses the geometrical concept to find the location of the node in the 2D and 3D plane. But in training dependent approach, that uses the past data or the history to find the location of the node. And generally, in the geometrical approach, these are the attributes: received signal strength indicator, phase of arrival, and angle of arrival, time of flight, time difference of arrival, return type of flight. These are the attributes they are used to measure the distance between the nodes. So in my paper, I am taking the RSSI. Now, in the training dependent approach, generally skin analysis and fingerprintings are used. Generally, different RSSIs are collected during the offline phases, means the history is collected, and the position of a node is calculated with the help of the history. And there are two approaches. One is the probabilistic methods, another is the intelligent method used in training. So these are the communications generally used in the IoT, Wi-Fi, Bluetooth, Zigbee, so on and so forth. And my motivation is, what is the motivation behind this paper is, in a non-GPS environment, how to find out how many anchor nodes are required to cover all the nodes, and it gives the right kind of positional value or right kind of positional information. This is the motivation. This is the problem statement. Problem statement is the same in the non-GPS environment. How many anchor nodes or how many beacons are required to cover all the sensor nodes. So I have gone through different types of anchors. One is GPS based anchor, another is non-GPS based anchors. But in the GPS based anchors, there is a need of satellite communication. So in angle of arrival, if you compare it with the RSSI, it provides with a high localization accuracy, but the disadvantages is it requires directional antennas. So it increases the cost and increases the weight. And it also deteriorates when there is a distance increase between the transmitter and receiver. And if you take the attributes the time of flight arrival, it provides higher localization accuracy than RSSI, but there is a need of time synchronization between the receiver and the transmitter. So there is a need of a timestamp. And here, another disadvantage is the line of sight is compulsory for accurate performance. Next one is time difference of arrival. If you take this attribute, accuracy is better than RSI, and it doesn't require any timestamp. So these are the advantages. And but here the reference node, at the anchor nodes, they require the clock synchronization with each other. Return time of flight provide high accuracy locality, doesn't require any clock synchronization. But the disadvantage is it is only applicable to symmetric path between the transmitter and the receivers. But in training dependent approach, there are here the main concept is different RSSI values are collected, which is taken as the history and in the offline phases, and the history is used to find the location of a node in the online phases. And there are two approaches. One is the probabilistic methods, another is the intelligent methods used in training. So these are the communication technology used in the IoT, Wi-Fi, Bluetooth, Zigbee, RFID, so on and so forth. And this is my motivation. My motivation is in a non-GPS environment, how many the numbers of anchors are minimized, are optimized, so that it will cover the all the nodes, and it gives the accurate positional data or the positional information. That is my motivation. And the problem statement is hence the proper distribution in the whole network and the reduction of anchor nodes in the deployed area along with an intelligent computation technique to reduce the environmental noise are the prime goals in finding the location of smart devices in IoT. And these are the literature survey. I have differentiated between the GPS based and non-GPS anchor. In GPS based anchor, it requires satellite communication, so that it is costly. But here the accurate it gives you the high accuracy. It consumes more power and it gives the global coordinates. But in non-GPS anchor that doesn't require in satellite communication, it is cost effective, obviously low cost, low power consumption. It gives the local coordinates and relative accuracy. And there are two types of anchor noding positioning methods are there. One is pre-anchor positioning, another is the post-anchor positioning. In the basic difference between pre-anchor positioning and post-anchor positioning is in pre-anchor positioning, the anchor nodes are deployed first. After that, the things or the sensor nodes.
Dear presenter, sorry to interrupt. Please conclude in your presentation.
Okay, so let me. This is my proposed algorithm. Is it visible, sir?
Yes.
I'm just drawing. Actually, we developed previously. We developed the algorithm, the berry algorithm. In that algorithm, we have taken just a minute, 1 minute. In the plug the berry algorithm, we have taken a polygon. We just place a anchor, and every if you place an anchor node here, and it has a transmission range, and we place another anchor, and the internode distance is 2 if root 2 r. If r is the transmission range, now another anchor is placed, and it will be checked. It is a 0 degree comparison with the first node. This is the second anchor node, and we are going to check how many acknowledgement it received. Similarly, we just place another anchor node here and check how many acknowledgement it received. Similarly, our 90-degree position, but we cannot place an anchor node because it is out of the boundary. Now we are comparing S1 and S2. Which one gets the maximum acknowledgement? That is the position of the second anchor node. This is my previous plug the berry algorithm. But in your proposed algorithm, in every position we are placing the anchor nodes, and this is the result. In the plug the berry techniques, number of anchors are required is 35, but 10 sensors or 10 things are not covered. But in developed diagonal techniques, the paper which I have depicted in my paper, here the number of anchor nodes are more, but almost all things are covered. So this is I have taken 100 trials, and I have employed 200 sensors, and this is the on snapshot. And the conclusion is, if I'm comparing two algorithms, plug the berry and the developed diagonal algorithm, in plug the berry algorithm, number of anchors required is less, but some sensors are not covered. But in the developed diagonal algorithms, almost all sensors are covered, but the number of anchors required is more. So my future plan is I'm going to develop a optimized technique through which almost using less number of anchor nodes are used to calculate the positions of all sensors. These are my reference papers. Thank you.
Okay, thank you so much for your presentation. Jay, please announce the next presenter.
Next presenter is Rishika Shivnani, and her paper title is Image Generation Using Sketch and Attributes. Ms. Rishika, are you there?
Yeah, sir.
Yes, complete in time. We have limited time, so
Yeah,
thank you.
I'll just share my screen. Is it visible?
Yes, you can start.
So good afternoon. I'm Rishika Shabnani, and along with Darkan Moinani, we are here to present a paper on sketch to images using attributes. So generally, generating a photographic image has always been an extremely important issue. So and sketch images normally contain simple information, not the details and all the attributes of the face. So that's why we are using sketch along with attributes to generate a real life photographic image. This is done using GAN algorithm, that is generated adversarial network. Our motivation for this project was we can use this in concept arts, build world building, so that the directors in movies can convey their vision very clearly, and that the production requires a lot lesser time than it used to. This can be also used in gaming architecture to design the model, how it will look after the building. So this is our architecture of our project. We are using GAN algorithm. GAN basically consists of two generative networks, that is the generator and the discriminator. The generator learns to generate data. That data becomes negative training examples for the discriminator. As you can see, the generated data, that is the fake samples generated, fed to the discriminator, and then the discriminator decides that the generated image is real or not. So as the training progresses, it becomes very hard for the discriminator to decide whether the generated image is fake or not. So they both run hand in hand. The and they both run hand in hand, and this is done through backpropagation, that as you can see, the generative loss weighs itself through the discriminator to progress, and the discriminator loss, that it whether it fails recognition of fake images, that is fed to discriminator. So for our project, we are feeding the generator with input sketch and the image. They both go into discriminator, and then the generator's output is fed. If the output is correct, the discriminator basically loses to generator, and if the output is incorrect, discriminator wins. That is, it recognizes where the fake generated image is actually a fake one and not the real one. So we are also, after that, that the generation of realistic images, we are then using star GAN algorithm to put on attributes. Before this, the generation of images is done using conditional GAN algorithm. We're using conditional GAN algorithm because in conditional GAN, there is a condition that is to be fed to the system, and in our case, that condition is the sketch input, so that it's easier for training and requires less time. Now, star GAN will be explained by Dharkan.
Yeah, so as Rishika mentioned, for converting the image along with the attributes, we are using StarGAN model. So StarGAN, what are basically StarGANs used for? So given training data from two different domains, these models learn to translate image from one domain to another. For example, we are having an image. We have converted the image, sketch image, to the real image, and we are changing the hair color, that is the attribute of a person, from black to blonde. So we denote domain as a set of images sharing the same attribute value. So people with black hair would be one domain, and people with blonde hair would be the another domain. So this is about the StarGAN model. Now coming next to the working of the training of the model to increase the efficiency. So basically, as you can see in this slide, this was the first trial which we got while training the model. So while training the model, we trained the model for 40 epochs. So in order to improve the image accuracy, however, it caused the overfitting of the model. So some of the heuristics were applied to the model, which included upsampling and downsampling approaches. As you can see in this image is somewhat similar to the sketch image, but not the replica of the ground truth. This happened because of the overfitting model. So in the next trial, what we did was we applied some label smoothing and utilizing different batch normalization, one-sided label smoothing, and different batches of real and fake pictures. So as Rishika mentioned before in the procedure of the discriminator, so there are chances because of the overfitting, there is a zero-sum game between the discriminator and generator. So because of the overfitting, the discriminator produced the false images. So that's why we have done the pre-processing part to get the proper output. So when training the model, label smoothing is performed, which might have a regular impact. And the photos which we sent into the discriminator, as mentioned by the Rishika in the input, were having a regularizing impact. The photos were sent in which were having the pixel values in the range of -1 to 1. So these were some of the GAN heuristics which we applied to increase the accuracy of the image and to reduce the overfitting and to produce the proper output. And as you can see in this slide, we have converted the sketch to the image, and this is the ground truth in the middle itself, which you can see. And we have converted this ground truth image using StarGAN model to various attribute guided images, like the image with black hair, blonde hair, and then image with ginger hair, then the image with a little brown color, and then an aged version of that image. So this was these were the attribute guided images which we got after training this model for 40 epochs. And as you can see, this is the final predicted output of the GAN model. We have trained our GAN model for 40 steps, which took about 2 to 3 days to train it. Yeah, so now talking about the accuracy measures which we have applied to our GAN model. So we have done the accuracy using MSE, SSIM, and PSNR values. So briefing about these three. So first, starting with what is PSNR. So PSNR is basically, to improve. And also, I would like to add that to improve the perceptual quality of the images, we also have added the adversarial loss while training the model.
Dear presenter, you have last 1 minute.
Yeah. So SSIM, PSNR, and MSE values were calculated. So looking at the MSE value, it is hard to tell the difference between the images. So we have used the SSIM technique to tell the relationship between output and generated output and this. So SSIM value was 0.267, which is found to be a good SSIM value. So we have trained the model and we have compared the SSIM models after training it for various amount of time. So coming to the conclusion part, we used two models, that is the conditional GAN and StarGAN model, to convert the sketch to the image, and then converting that image to converting into the attribute guided images. And we have done a lot of GAN heuristics to reduce the overfitting and to improve the efficiency of the model. Yeah, so that's it.
Okay, will you please tell me, is there any range for SSIM?
Yeah, SSIM values range between 0 to 1. So
0 to 1. Okay.
yeah,
Okay.
so
And you have achieved
SSIM.
0.8.
Sorry.
You have achieved up to 0.8.
No, 0.38. So this is 0.28 is a good SSIM value, but we have received 0.3891. So it's also a good range. Like good range of SSIM comes between 0.2 to 0.4. So we have received.
Okay, good. You have done the very nice presentation. Thank you.
Thank you so much, sir.
Jay, please announce the next one.
Thank you so much for kind presentation.
Thank you, sir.
Next is Syed Saad Hussain, and his paper title Evolution of Cryptocurrencies and Sentiment Analysis, Correlation Analysis. Please complete in time. Thank you.
Yeah. Hi, everyone. Let me just share my screen. Is my screen visible?
Yes, you can start.
Yeah. So the topic for the today presentation is the evolution evolution of cryptocurrency and sentiment analysis. It is a correlation analysis. I'm your host. I'm your presenter, Saad Hussain from Pusat College. So to start with, the cryptocurrency is a virtual asset which is intended to work as a standard of transformation that makes use of robust cryptography. This will help us in to protect monetary communication, that is transfer of money, switch the introduction of supplementary devices, confirm the transmission of belonging. That means basically that when the transaction is taking place between two parties, we know that the correct party has shared that. However, in current scenario, the cryptocurrencies are highly unstable. There are with the advancement of cryptocurrency, many people are using it to. Many people are portraying their thoughts on the social media, due to which there are a number of newscasts which are tweeted and retweeted with the aid of consumer, and which might spread to the massive viewers. In this paper, the intention is to suggest a methodology in which we can visualize or envisage the association among the cryptocurrency and with the sentiment of the post, or if a person have this or the the number of supporter that the person have, the number of retweet that has happened, or the range of likes. In this paper, we have proposed for the real-time visualization of the advancement of tweet score. To start with the introduction, Bitcoin is currently the biggest cryptocurrency in the world. It is primarily decentralized virtual forex, as it is function without a set of or solitary supervisor. It means that it does not have a particular owner, we can say, but it is a peer-to community-based cryptocurrency. It function as mentioned. It is function as a peer-to-peer community in which communication takes place between the operator, and there is no midway. So there is no broker between them. Another cryptocurrency which is studied in this paper is Zilq and Nexo. Zilq is basically a cryptocurrency which uses a technology called as sharding methodology, in which allows us the operation, which permit operation codes to upsurge as the system enlarge to scale with the boom of Colliers. And Nexo is also a cryptocurrency which provides us with the loan facility to the stockholders and corporation, so that they can get an immediate cash, whereas they maintain the proprietorship of their virtual assets. Now, the APIs used are the crypto compare, which is a API which allows us to reclaim the crypto exchange. It provides us with the specific endpoint using which we can fetch ancient statistic based on a time and within a 7-day period. Okay, the information which this API provides is the instance the data is produced, basically when the data was produced, what was the highest cost at that time based on time, hour, minute, and hour, lowest cost which is to reach, and the cost at the opening hour. And for getting the sentiment data, we use Twitter API, and for filtering, we use the querying mechanism which is provided by Twitter API itself using keywords and hashtag. So in this paper, we have this paper contribute for reclamation of the message from Twitter API, recovery of cryptocurrency alteration using the crypto compare, the emotion evaluation of the message with the use of radar, which is a kind of dictionary based of rules. It provides us with the calculation. We have done the calculation rating totally based on emotion, number of likes, variety of messages, and the number of fans the person that tweeted. A calculation and visualization of association score with the unique intermission value among the message ranking and the cryptocurrency modification in US dollar. And we in this paper has also contributed in introduction of real-time visualization version of the association among the messages using different association techniques. I mean, later on, an RNN network can also be trained to expect the forex of either Bitcoin or other cryptocurrency based on message ranking and the cryptocurrency trade. And acquisition and the sale of the cryptocurrency may be computerized with the qualified community. In this, some of the related work which has been done of sentiment analysis with cryptocurrency has been explained. One work has been done on neocoin, that is altcoin. This is also one of the cryptocurrency. In this currency, in this paper, a random forest classifier is trained and tested based on the label statistic. Here, it might discover the fine association between the number of messages and the everyday charges among the cost of diverse cryptocurrency, though it is done on the neo
Dear presenter, so to interrupt, your last 1 minute.
blockchain technology has also been used.
Hello.
Yes.
You have last 1 minute, sir.
Okay, so let me go to these are some of the related work which has been done. This is the explanation of algorithm, in which basically what we have done is we have filtered out the messages. We have determined the composite of the remaining messages. Based on that composite, we have done the calculation. Formula is present over there. And once this message rating is calculated, we have done a sentiment analysis to determine what kind of emotion it is, whether it is a good or impartial emotion. And once this rating is calculated, a cross relation between this rating and sentiment has been done with the help of 3 techniques, that is Spearman, Kendall, and Pearson. And as I have already mentioned, Vedder is the dictionary used, which basically provides us with the vocabulary. So, as due to the this amount of time, I won't go into it. So here are some of the result. This is the result before applying normalization. Sorry, before derivative, applying derivative on the cryptocurrency, and this is the derivative of cryptocurrency and sentiment score. Okay. So this was done with the help of Bitcoin. This graph. However, this is, as Bitcoin is very large, it is very difficult to determine which factors are affecting the value. So due to that, later on we went to the other cryptocurrencies. This is again the association which were calculated based on the Spearman, Kendall, and Pearson association techniques, cross correlation techniques. This is in the range of 1 to -1. I was unable to take a proper picture of this. Okay. And this is the result, which is for the Nexo Bitcoin, and this is the derivative of the cryptocurrency and the sentiment score based on the values which we have received. Now, we can examine that for the different cryptocurrency, in every foreign currency, what happens is there is a massive spike in Twitter emotion, the forex changes. However, in some cases, the price will also increase in case of the negative Twitter emotion. For this purpose, LSTM algorithm can also be used to determine why this huge spikes and
Dear presenter,
relation
please
between
conclude.
this score and the spike. Lastly, in conclusion, again, it is very tough to determine why the value of cryptocurrency is changing based on the Twitter emotion. There are multiple issues which can affect them. Currently, we have done only with the help of 7-day data, which is provided by the cryptocurrency. However, we can maybe the performance can be better based on the 12 hours data. And lastly, I would say that if a machine learning algorithm like neural network is applied, this can definitely help us in improving the forecast. After tuning proper hyperparameter, we will be able to determine it properly. These are some of the references which were used. Thank you.
This sentimental analysis is for the crypto investor or crypto trader.
Sorry, come again.
You have done the sentimental analysis in cryptocurrency, right?
Right, correct.
So on the basis of analysis of crypto trader or crypto investor, on which basis you have done such kind of analysis?
We can say it is mostly based on the trader,
Trader.
normal trader, not as an investor, a big investor. Because if there is a big investor, this will lead to a massive spike. I mean, if a person, like a billionaire invests in that, it will definitely result in the massive hike. So that can be helpful for the normal trader.
Big investors in this market, big investors can be called as a whales.
Yes, those are whales or shark, we can say, and they are basically responsible for, we can say, maintaining the Bitcoin. I would say, I mean, based on their investment. So they have also suffered a lot of losses over the time.
With all the presenters are done. I sincerely thank our authors for their excellent presentation and all our authors for being a part of this international conference. I hope this session was informative enough. We on behalf of whole team, thank you so much for the support of this version and previous 6 version of the conference. And we're happy to have you in 8th version in 2023. All the presenters will be getting their digital certificate in 2 working days through email. Further, all the papers are already forwarded to the Stinger. The publication will be live within 5 to 6 months. Kindly cooperate with the team of ICT4SD. The last, I would like to thank our session chair, Vinod sir. So there is a token of appreciation on behalf of Global Knowledge Foundation and ICT4SD. Thank you, sir, for a valuable time.
Thank you so much. Thank you to all the presenters.
At last, I would like to request on turn on their cameras for a quick snapshot. Please turn on their cameras. All. Thank you so much, John. Thank you, sir. Have a nice day.
Thank you.